This is a problem about a rod in a ball. A rod in a ball. The original question is this. A rod rests wholly within a smooth hemispherical ball of radius r. The center of gravity dividing the rod into two portions of length A and B shows that if theta be the inclination of the rod to the horizon in the position of equilibrium, then to prove this is a result of sine theta. After that, and find the reactions between the rod and the ball. For this part, we have an earlier video in which we proved sine theta is equal to this. But now, the second part, we want to show what the reactions are between the rod and the ball. And in this part, I uploaded a statement. Your solutions are appreciated. And I have a response from Claire Lee, and she provided the solution. Today, I'd like to present Claire's solution and add explanations to it. So, let's start. So I have a ball. The ball is hemispherical. If the rod is uniform, then the center of mass must be in the midpoint. So this is a rod. If the rod is uniform, then this must be the center of gravity. It's in the middle. So if this is the case, then the rod resting in the ball should look like that. So this is the center of mass. So look like that. However, the question says the center of mass divides the rod into two portions, A and B, which means the rod is not uniform. For example, I have a rod, this side is bigger and the other side is smaller. Then the center of gravity should close to the larger end. That is the weight. So the question says this part is A and this part is B. That's the question. If this non-uniform rod resting in the ball, how does it look like? Then I have a ball. If the rod is not uniform, then I should have something like that. This is the center of mass. The heavier end, the larger end, should be lower than the smaller end, right? Yeah. So this should be the situation. So A and B. And that is this part of the question. That is dividing the rod into two portions of length A and B. Next thing we consider is this word, smooth. What does smooth mean? Smooth means there is no friction. So here, at this point, the resting point, there is no friction here. And also here, there is no friction. If there is no friction, then the force acting on the rod at this end must be perpendicular to the ball's surface, which means the reaction force is 90 degrees here. That is what it means by there is no friction, or the word smooth. Similarly, at this end, the reaction should be perpendicular to the ball's surface. This should be 90 degrees. That's what it means by the word smooth. Now, if I extend the reaction into the ball, and I extend this reaction into the ball, then you see, because this is 90 degrees, this should be the radius, right? And this should be also the radius. Therefore, the two radius will intersect at the center of the ball. The ball is a sphere. So in this two-dimensional drawing, this should be the center of the circle. So radius, and the reaction. Okay. That's the forces, reaction here, and weight here. So I have three forces acting on this rod. And the rod is not moving. It's in equilibrium. Now, I need to introduce a theorem. Here is the theorem. This part. If three forces acting in one plane, all the three forces are on the same plane, and acting upon a rigid body. A rod is a rigid body, okay, acting upon a rigid body. Keep the body in equilibrium. And that is exactly our situation. Then what happens? The theorem says they means the three forces. The theorem says the three forces must either meet in a point or be parallel. In our case, I have three forces, 1, 2, 3. The three forces are not parallel. Because they are not parallel, yet the rod is in equilibrium, and all the three forces are in the same plane, then the three forces must meet in a point. In this case, two forces already meet at the center, therefore this weight must pass through the center. So my drawing is a little off. So my drawing, this must be the center, and the weight is here, and the weight must pass through the center of the circle. And this is A, and this is B. So far we have the geometry. Let me summarize the geometry again. I have a half circle. Center is here. I have three forces. This one, and this one. The two of the three forces are along the radius of the circle. And of course they meet at the center. And the third force, according to the theorem I just presented, this third force W, the weight, must also pass through the center. Now we come to the last part of the question, the second part of the question. The second part is find the reactions between the rod and the ball. This is reaction. This is reaction. So I need to find how big this force is and how big this force is. Let me redraw the three forces and let the three forces meet at this point. So I redraw these three forces here. So this is the center of the circle. So one force is this way, another force is this way, and the weight is this way. Okay. Let's label the two reaction forces. These are the two reaction forces. Say R1, reaction 1 and reaction 2. Okay. How to find R1 and R2? Then I need another theorem. Another theorem is called this, Lami's theorem. By the way, I'm not sure whether I pronounce this correctly. This is, I think it's an Indian mathematician. So Lami or Lami, I don't know which way is correct, but that doesn't matter. So this theorem says what? If three forces acting on a particle keep it in equilibrium. So I have three forces, 1, 2, 3, acting at the center. You may consider this center is a little particle. You can consider that. So I have three forces acting on a particle. Continue this theorem. Acting on a particle. Keep it in equilibrium. Keep the particle in equilibrium. In our case, the rod is in equilibrium. Then each means each force. Each force is proportional to the sine of the angle between the other two. other two forces. Okay, so each force is proportional to the sine of the angle. What angle? The angle is the angle between the other two forces. So go back to this question. Go back to this diagram. This force is proportional to the sine of the angle between the other two forces. Other two forces is this and that. This force is proportional to the sine of this angle. This force, R1, is proportional to the sine of this angle. R1 proportional to the sine of this angle. R2 is proportional to the sine of this angle. So we can write down the three ratios. This divided by sine this angle. This divided by sine of this angle. This divided by the sine of this angle. All of these three ratios are equal to each other. And that is what Lami's theorem tells us. So I need three angles. All right. So go back to this. I think I need to redraw this. This is a mess here. Let's see now. How do I redraw this? Maybe I should use another piece of paper. Okay. Okay. So let me make this drawing very big. This is a rod, and say this is the center of the circle. So one force is this way. This is the reaction. And another force this is the reaction, and another force is this. Okay. In the first part of the problem, we have proved sine theta is equal to something. Where is this sine theta? Sine theta is you pass through this point, you draw a line, a horizontal line. And this is theta. This is the first part. Sine theta already proved to be something. Now look, this is the weight. Of course, it's vertical. And this is horizontal. So the weight and the horizontal line intersect at 90 degrees, right? All right. R1 here, R2 here, and they intersect at this common point. Okay. Oh, by the way, this is our radius, and this is our radius. And this part is A, and this part is B. So this triangle is fixed because all three sides are given this. Radius, and this side is a plus b. Because this triangle is given, the size is given, then I can find this angle. Let's call this angle phi. Look, this side is equal to this side. The triangle is isosceles, so this angle and this angle are equal. Okay. Now, I want to find this angle, and this angle. Once I have these three angles, I can write down a relation according to Lami's principle. This angle is easy to find because you look at this. This is 180 degrees. This is 180. This is 180. How big is this? Look at this triangle. This triangle. This angle is called exterior angle or exterior angle. This exterior angle is equal to this angle plus this angle. That's a result from geometry, right? This angle is phi plus phi. So it's 2 phi. This angle is 2 phi. But from here to here is 180. Therefore, this angle is 180 minus 2 phi. (180 minus 2 phi). So I have this. How about this angle? This angle is 180 here, 180 minus this angle. What is this angle? I look at this right triangle. This is a right triangle. You see here? 90 degrees, right triangle. So what is this angle then? This angle is 90 degrees minus the sum of phi and theta. So this is 90 degrees minus phi and theta together. So this is right triangle, so 90 minus that. Therefore, this angle is 180 minus this. This is 180 degree minus 90 minus phi plus theta. Right? So you can simplify this. You simplify this. Is 180 minus 90 degree minus it's plus. So plus phi plus theta. Yeah, this is, and then this is equal to 180 minus 90 is 90. So it's 90 90 plus, oh, I run out of ink. I'm sorry, give me 1 minute. I get a new pen. Okay, I'm back. So this is 90 degree plus phi plus theta. So this is this angle. You see from Lami's theorem, I need this angle, and also this angle, right? This angle. So what is this angle then? Okay, so I run out of, I need this angle. I need this angle. So this angle is this angle plus this angle. It's 2 phi plus this angle. So this angle is 2 phi plus 90 minus theta, phi plus theta. And this is 2 phi plus 90 minus phi minus theta, right? Minus phi minus theta. Okay, this. And this is, let's write 90 degree first. 2 phi minus phi is just phi. And then minus theta. So this is this angle. Then I can write down the Lami's theorem. Okay. R1 over sine R1 over sine this angle. Sine this angle is this. So I have sine 90 degree plus phi plus theta equals R2 is this. So R2 over sine this angle. So this angle is here. So R2 over sine this angle. Okay. Equals W divided by sine this angle. So I have W sine this angle 180 minus 2 phi. Good. That is my Lami's theorem. Now I use trigonometry identities sine 90 plus something is cosine this. Therefore, this is cosine phi plus theta. Sine 90 plus that is cosine this part. Cosine phi minus theta. Equals W over sine 180 minus that. Then there is another identity. Sine 180 minus that is just sine 2 phi. Okay, I have Lami's theorem, this, and simplify the denominator, I get this. Now what do I do next? I need to use trig identities. Cosine A plus B is cosine A cosine B minus sine A sine B. Cosine A minus B is cosine A cosine B plus sine A sine B. What is sine 2 phi? Sine 2 theta, let's say sine 2 theta. Sine 2 theta is 2 sine theta cosine theta. So the next step, we use the identity to write out the denominator. Okay. I like to stop for a while and continue with all the identities because it's quite long for this part. So I like it's a good idea to stop for a while. So let me call this part 1 of the solution. And in a while, I'll continue with part 2 of the solution. So this is just a pause. Okay, to be continued. To be continued. This is part 1. Okay, sorry for that. It's too long. I need a break. See you later.